Okay, in this video we are going to solve x plus y plus z equal to 6, x plus 2y plus 3z equal to 14, x plus 4y plus 7z equal to 30. Okay, so if you see, there exist constant values, so this system of equations are said to be non-homogeneous. Very good, these equations are said to be non-homogeneous equations. So you write as usual, the given equations are containing constant terms, so that the equations are said to be non-homogeneous equations. And the given equations are like that. You can write first x plus y plus z equal to 6, make it as 1. And second, you can write x plus 2y plus 3z equal to 14, make it as 2. And third equation you can write in vertical method. Okay, x plus 4y plus 7z equal to 30, equation number 3. So first I'll write coefficient matrix. X plus y plus z equal to 6, 1 1 1. X coefficient 1, y coefficient 1, z coefficient 1. Here x coefficient 1, y coefficient 2, z coefficient 3. Here x coefficient 1, y coefficient 4, z coefficient 7. What is my x matrix? What are the variables? X, y, z. Here what is my B matrix? 6, 14, 30. These are the constants. So how many variables here? Number of variables, you can take it as a note. N is equal to xyz 3. You can keep aside this one. Okay, it will be used in by the end of the finding solution. Okay, now my augmented matrix A by B or AB. 1 1 1 6, 1 2 3 14, 1 4 7 30. So this has 1, so ignore it, make these are zeros. R2 tends to R2 minus R1 comma R3 tends to R3 minus R1. 1 1 1 6, I'll not change. 1 minus 1 0, 2 minus 1 1, 3 minus 1 2, 14 minus 6 8, 1 minus 1 0, 4 minus 1 3, 7 minus 1 6, 30 minus 6 24. Okay, R3 tends to R3 divided by 3. Okay, so what you will get? 1 1 1 6 0 1 2 8 0 3 by 3 1, 6 by 3 2, 24 by 3 8. So R3 tends to R3 minus R2. So what you will get? 1 1 1 6 0 1 2 8, 0 minus 0 0, 1 minus 1 0, 2 minus 2 0, 8 minus 8 0. So that's it. If you do any operations on R2, this value will come. So no, don't do any operations. Okay, now what is my rank of A? Rank of A means this is rank of A. So you have to see this one, this matrix. So how many non-zeros? Rows 1 2, this is becomes 0, so we will not consider. 1 2 2, so rank of A is equal to 2. What is rank of AB? Entire matrix 1 2 3. But here this also 0, so rank of A by B is equal to 1 2 only. Okay, so here rank of A is equal to rank of A by B. So the rank of A is equal to rank of, hence the equations are said to be consistent. Because rank of A is equal to rank of A by B, the equations are said to be consistent. And rank of A is equal to rank of A by B is equal to 2, but it is less than n. N, how much n? N is equal to 3. It is less than n is equal to 3. So the equations are consistent but having infinite many solutions. Why? the rank of the augmented matrix and A matrix is less than the number of variables, even though those are equal, hence these equations are consistent. But because of the where rank is less than the number of variables, these equations are consistent but having infinite number of solutions with how many arbitrary values? N minus r. What is n? 3. What is r? This is r. What is r? 2. 3 minus 2, 1. One arbitrary value we have to take. How to take arbitrary value? I'll explain you here. That is the solution, nothing but solution. 1 1 1 0 1. I'm writing this matrix only. See, 0 1 2 0 1. See, 1 1. Reducted form is 1 1 1 0 1 2 0 0 0. This is reducted A matrix, and x y z 680 reducted matrix only I'm writing. Okay, so x plus y plus 1x plus 1y plus 1z equal to 6. This is equation number 4. 0 into x 0, 1 plus y plus 2z equal to 8. This is equation number 2, sorry 5, because first we took 1 2 3 plus 0 0 0 0 z equal to 0. 0 into z equal to 0, but we have to take one arbitrary value, so hence we consider z equal to k. In what we got in homogeneous equation solving method, something into z equal to 0. Here not 0 we got something else, so something into 0 should be 0. Okay, but here what we get? 0 into z equal to 0, so we consider z equal to k. But in homogeneous equation we got 9z. 0 into z equal to 9. 0 into something we got value. See, 0 into z we got some value, but 0 into something should be 0, right? Here we got 0 into z is equal to 0 only, but we consider this as arbitrary value. Z equal to k means z is having some value, but because of this 0, this entire resultant becomes 0, so we consider z equal to k. Okay, this must be having some value, z equal to having some value, but the thing is we are multiplying with 0, hence it is becoming 0. We are assuming like that, so we are considering z equal to k. This is arbitrary value. How many arbitrary values we have to take? Only one arbitrary, so z equal to k. This is sixth equation. Submit 6 in equation number 5. Y plus 2 into z plus in place of z you can write k. Y equal to 8 minus 2k. Okay, what submit this y value in this equation. X plus 8 minus 2k plus z, what is z? K is equal to 6 minus 2k plus k. X plus 8 minus k is equal to 6. X equal to 6 minus 8 minus 2 minus k plus k. X equal to k minus 2. So the result is x y z is equal to x value k minus 2, y value 8 minus 2k, z value k. This is the solution for every k value. K equal to 0, minus 2, 8, 0. K equal to 1, 1 minus 2 minus 1, 8 minus 2, 6, k 1. Like that, for every value of k 0 to infinite, you get infinite number of solutions. This is consistent and infinite solution solving method. Okay, if you have any doubts, do let me know in the comments. Thank you. With this we have covered inconsistent. First we solved homogeneous, then we solved inconsistent, then we solved consistent with unique solution, that is rank of a by b is equal to rank of a is equal to number of variables. Later in this video we solved consistent equations with infinite many solutions, that is rank of a by b is equal to rank of a but less than number of variables. With this we have covered the entire system of equation concept. If you have any doubts, do let me know in the comments. It is revision purpose. That's it for today. Signing off, Rajesh Balaka. I have to go office here.